Hey everyone, thanks for taking a second to look at some of the work that I put together for our final project. Out of the gate, I'd say that I've linked this in my discussion. I'd encourage you to go there. Based on time, I'm just not going to be able to touch on everything. But what I'd say is it's a good outline of how I've put together my paper, which is obviously still a work in progress. And although it doesn't go into the same depth, covers a lot of the pieces. But I am going to be jumping around in this recording. So if you want to see the whole thing, feel free to click in. In terms of problem and significance, I'm going to gloss over that. I think we're probably all relatively aligned on what that is. Data exploration, there's a few things I'll highlight here. So in addition to just, the normal looking for null values, kind of understanding the data. So I looked at the date ranges by restaurant, things like that, just to get a sense of what I was working with. Some of the things that I really want to talk about are one big change that I made. I wasn't hugely satisfied with the hierarchy. Not that it wasn't good. I understood that within an area there were certain restaurants. I just didn't feel comfortable talking about each area as though it was a very separate geographic region. One of the things that I wanted to try to build in as an exogenous variable was the number of similar restaurants in an area. And I wanted that to be based on how people would make decisions. And so thinking about myself, I don't necessarily think, oh, I live in the west end of Portland, which is a place I used to live. And so I can never go to the east end of Portland. I think I live in downtown Portland and they both kind of cover that. So what I did was build a grid of 25 square mile ranges, which may have been a little generous, but I thought that, 5 miles east west, 5 miles north south, that's probably about how far people are willing to travel. And what that ended up doing is shrinking that hierarchical variable of the range. So I was able to get every restaurant into 51 25 square mile ranges instead, which I think allowed for better use of that exogenous variable, at least better research into it, and just aligned better with human behavior maybe. So I did that. And then finally, a lot of my data exploration is on these top 10 of those 51 ranges, which covered about 72% of all restaurant visitors in the training data set. You'll see this box plot here. I'll touch on what I did with reservation rates in a second. In terms of data distributions, we'll see more of this. I'll highlight, there was clear seasonality Monday to Sunday, where visitors grew throughout the week, shrank a little bit Saturday to Sunday, but overall higher on the weekends, lower in the work week. The box plots kind of showed that trend as well, although outliers kind of skewed the scale and made it difficult to read those. The number of restaurant visitors by 25 square mile range, there's clear differences in how, this is a very bumpy horizontal line. And so ultimately what this said to me is, you at least have to model at the level of the range. You can't model all the way at the top and then try to distribute one down to the next, probably. Plots of the data confirmed some of what I saw up here in weekdays, but also just gave me a better sense of visually what I was working with. So in terms of the aggregate data, there's clear seasonality week to week. There's this huge jump in July 2016. There's this huge drop in January 2017. The drop is definitely New Year. The jump in July 2016 seems to be an actual change in how data was collected. I don't know that definitively, and so I'll talk about how I dealt with that. Seasonality, again, proves that restaurant visitors seem to grow throughout the week, dropping a little bit on Sunday, and this gap between is that jump in July 2016. So in the top 10 ranges, these visual plots are roughly the same. I mean, this one, not quite the same, but it definitely seems as at July 2016, there's a pretty level shift in how the seasonality variability grows. Seasonal plots look pretty similar, so I won't touch too much on those. I did consider some other variables. I've talked about the similar restaurants, which didn't really seem to add a lot of variability in visitations. The thought was, if there's a lot of the same, you probably have one really popular one that there's all the overflow goes to the other ones. I didn't really see that. My thought is, if you have a lot of the same restaurants, you're living in a more populated area, would be my guess as to why there's no relation. Holidays, I'd be really curious to see what others found here. I did not see that they had a huge impact on visitors. I mean, there's definitely a shift in the outliers. That makes sense. There's less holidays than there are not holidays. So I'm not surprised there's not as many outliers, but in terms of this box, didn't seem like there was a huge difference. The same is true. What I did with the reservation data is not use it as a pure count. I didn't think it captured truly how restaurants get all of their reservations for a specific date, because it doesn't include reservations made through the phone. It doesn't include the reservations made on sort of a walk-in. It just includes those reservations made through the AIR and HPG platforms. And so what I thought I'd do is create a dummy variable to say which restaurants get most of their visits through reservations through those two apps. And so the yes is to say these restaurants are the ones that most of their visitations are based on reservations out of the apps, and no is otherwise. And again, there's really not a lot of variation that I can see. And so I didn't have a lot of luck with including exogenous variables in my modeling. Not only was R throwing some errors that I didn't fully understand, full disclosure on that, but just generally, I didn't really see the value based on the box plots that I put together. I explored some outliers. So these are the restaurants where there was at least one observation of 250 visitors on a single day. They're clear outliers. I mean, I readily admit that. And in looking at them, I think, and maybe even after this presentation, I might divide these outlying points by 10, because they do seem to be just a double zero. This is roughly 250 where it averages maybe about 25. This is roughly 650 where it averages maybe about 65, 800 where it might average about 80. So that would be my guess. I think that would be a way to handle them. But then you get ones like this that just make absolutely no sense to me. Overall, what I'd say I've done here is I've left them. They didn't really seem to have huge impacts on these plots, aside from maybe this one right here. But overall, their impact on the level I was going to be modeling at was not enough for me to want to do anything with them, especially if for whatever reason they really are true observations and just a crazy night. I doubt it, but possible, I guess. I especially doubt it here. In terms of literature review, I'll say just two things. The modeling approach was fine in a lot of what I looked at. It didn't necessarily say it's the only way, obviously, but that is an approach I've become comfortable with this semester, and so that's what I chose, and it seemed to be validated through that literature review. Where I found a lot of general consensus was that where they talked about building in exogenous variables, they found that it is an enhancement to any model. And so I really wanted to. The spoiler on that is that I couldn't really figure out a way to, but just to mention that. So I've talked about my model considerations. Ultimately, I built 3. One on the full training data set was an auto ARIMA model. I went auto just to allow there to be different ARIMA models by range. It seemed as though there was some variation in the pattern of visitations, which you can see down here. This is the plots by range. And then I built 2 more models, but on an adjusted training data set, where I started at July 2016 as the first observation date. And this just acknowledged that not as maybe a shift in history, so a level jump to where it's always going to stay. I can't prove that, but it seemed as though it held for longer than it held for a good amount of the training data. And so for that, I built an auto ARIMA model and also an auto ETS model. Overall, I'd say they did okay. So on the full training data set, the auto ARIMA model, the residual plots largely look like white noise to me. Pretty constant variance, good normality. Some significant autocorrelation in the residuals as you get to these ranges that don't cover as many of the visitations. But again, overall, I felt like it did okay. Root mean squared error of 14.4 on the training data. And that was after I applied that at the restaurant level. So top-down approach using historical proportions. Looking at the knotted training data, so at July 2016 again, Similar results on the auto ARIMA side anyway, maybe a little more skew in this residual plot and this one down here, but largely representative of white noise, good constant variance. I got rid of that jump you'd see in these residual plots of July 2016. But generally, again, pretty good results. ETS did not have great residual results with significant autocorrelation sort of right out of the gate in these ranges that cover a lot of visitations. But both models performed equally well on the training data with a root mean squared error of 13.9. So the knotted models did better on the training data than the full training data set. But in terms of actual results, the model on the full training data set did perform the best. I ended up with a public score of 0.62, which is just below the median, which I don't have offhand, but I think it was like 0.601. So I'm not hugely happy with the fact that that I'm not even at the 50% mark for this. But I do want to focus on some things that I thought were positive. I felt like the models chosen really did cover the range data very well. I mean, if you look at these forecasts, I think you'd buy them. Yeah, I think they make a lot of sense. Where I believe I probably went wrong was choosing a top-down approach over maybe trying to do a bottoms-up. Something with the proportions is off. Anything. I mean, there's any real variability that can happen, and there's no real way to look into it. But I will say I think I chose the right modeling approach for the ranges. It just didn't translate as well to the individual restaurants. In terms of the knotted training data set, I got close to the same score with the auto ARIMA model, 0.621 versus 0.620. But again, overall, I think where I lost on this one was the fact that it doesn't translate well to the individual restaurants. So it modeled well at the range level, didn't necessarily do the same at the individual restaurants. And so that was definitely a limitation and the learning for me in terms of how you choose your hierarchy. It needs to be a very thoughtful approach between top down, bottoms up. I really would have liked a middle out approach. I thought that was sort of interesting. I don't think that would have changed much in this case, but just wanted to learn how to do it. And then in terms of exogenous variables, I found that really difficult to try to figure out how to bring that in. I built those I built a lot of those dummy variables at the individual restaurant level. So maybe looking back, I would have done that at the range level. But overall, I'm not displeased with where things landed. I would have liked a better Kaggle result, but I'm looking forward to seeing others and hope someone does beat that. I'd happily give up whatever point I'd get for having a higher score. But again, thanks for watching. I look forward to seeing what you put together, and yeah, appreciate all the support this semester as well.